Hello everyone. Today we're going to be focusing on Cambridge IGCSE Mathematics, the topic of algebra, subtopic of sequences and nth term. So to start off, we are looking at what is a linear sequence. So a linear sequence has the general form of un equals an plus b. And because there are no quadratic terms involved, we call this a linear sequence. And we always say that a and b will be certain constants, okay, that depending on the sequence it will change, and un we call is the nth term. So let's look at a more detailed example about what this is. So for example, if I have the sequence 6, 10, 14 and 18, for this sequence we want to try and obtain the nth term. So we want to write down what is un. So what do? Step 1, we put down the terms in a table. Okay, so we know that these are the first 4 terms of the sequence. So you write n is equal to 1, 2, 3, 4, right? And then next to that you have to write each of the terms, the first term, second term, third term, fourth term. The next thing you have to see is actually the difference between the terms. So in this case you can see that you are adding 4 each times. So therefore the value of a is the plus 4. So now that we have worked out the value of a, we have to find the value of b. So to do that, what you can do is you can introduce another column to your table, which is 4n. So basically you are multiplying the n value here by 4. So when you do that, you have 4, 8, 12, 16. And after that, what you have to do is from this value, how much do you have to add to get this value? Well, you can see each time you have to add 2. So hence the final equation is 4n plus 2. Alright. So moving on to the next equation, this is a quadratic sequence. un is equal to an squared plus bn plus c. So now you have an additional c term also coming in. Again, un still means that it is the nth term. And what you importantly need to know is that the second difference is going to be equal to 2a. So let's look at how would you work out this particular sequence example. So 2, 7, 14, 23, 34. So this time you still put it in a table, you still write the terms and you calculate the first difference, but you have to also calculate the second difference. And when I calculate the second difference, you can see that is 2. So remember we said that 2a is equal to the second difference. So therefore 2a is equal to 2, and from here I can work out that the value of a is 1. Then using the value of 1, I can substitute it into the common expression. So I still need to work out the value of b and c. So what you do is you ideally try to form 2 equations with 2 unknowns using the value of a. So by substituting, you can see that b plus c has to be equal to 2 and 2b plus c plus 4 is equal to 7. Right? So they have basically substituted the value in for n. So 1 as n, and then they have substituted 2 and n, and they have got the 2 expressions. And they are equating these 2 expressions equal to the 2 values 2 and 7. Once you have done that, you can simplify and obtain 2 simpler versions of sequences of equations. Now using these equations, you can utilize that method of simultaneous equations which we have looked at in our previous videos. So in simultaneous equations, the whole aim is always to try and solve. So in this case, since both of the expressions have a plus c, I can just subtract both the equations. So when I subtract that, I have 2b minus b is equal to 3 minus 1. So therefore b is equal to 2, and then by using that b value as 2, I can write 2 plus c equals 1. Hence c must be equal to negative 1. And finally, substituting all the values you have found for a, b and c, you can give the nth term in the equation form. The cubic sequence, we have to go a next step further, right? So this is the general form of a cubic sequence. You have a n cubed, b n squared, c n, and d. And this time we are looking at not the second difference but the third difference, and we know that the third difference is equal to 6a. So going by that, we again start with the same method that we have done earlier. You first write down the n value, then the term value, then you calculate not only the first difference, second difference, but third difference. And you can see here that the third difference is 6. So since this third difference is equal to 6a, you can then identify the value of a. From here, you then get an expression like this. So again, by the same method that you do in the previous one, you can substitute n values for 1, 2 and 3 this time, because you want to have 3 variables and 3 unknowns to find out 3 particular equations. Using those 3 equations, you can now try and do simultaneous equations, but in a way that it works for all 3 equations. So by doing that, you can see what they're trying to do is we're trying to remove one of the terms. Now since d is common for all the equations, it's easiest to use and remove d. So what we do is you subtract b and a, and you subtract c and b, so that when they are subtracted, you can identify a smaller equation which doesn't involve d and that involves only 2 variables that are changing. And using this, you can now do simultaneous equations. So subtracting this as 5b take away 3b and 9 take away 5, you know that 2b is equal to 4. So therefore you can find out that b is equal to 2. And substituting the b value into this equation gives me 3 times 2 plus c is equal to 5. So c is equal to 5 take away 6, which is negative 1, and that satisfies the value for c. And of course d value can be found also. So for that you have to go back and you can take any one of the 3 expressions here. So you can take 1 plus b plus c plus d is equal to 4. So we already know that c is negative 1, b is also 2. So using those numbers, we can then find that d is equal to 4 take away 2, which is 2. And that is how they have obtained the value of d here. And finally, remember that once you've worked out all the answers, you have to substitute everything in and get the final equation. So the next thing is geometric sequences. Unlike arithmetic sequences where you can add the differences, geometric sequences is basically multiplications. So here we are looking at what do I have to multiply from one term to get to the next term. So therefore it is 3, and this time ones where there is negative involved, you are multiplying by negative numbers. So in this case negative 2. And the nth term for a geometric series is this one, a r n to the power of negative 1, r to the power of n minus 1, that is. And what you need to do is basically instead of r, you have to substitute the value 3 and negative 2. And by doing that, you can see that you can find the nth term for each individual one. Remember, a is usually the first term in this case, so that's the reason they have substituted 2 there. And that brings us to the end of the lesson on sequences. Tune in to now do a few questions. Alright, so let's start off by doing a few questions to finish off. So we have the first 5 terms here, so we can start by writing the n value as we saw in the notes. So n is 1, 2, 3, just let's take that. And we have the term which is negative 3, 0 and 5. Okay, let's take 4 and 5 as well. So this will be 12 and 21. So going from there, you can then see that the increase here is 3, increase here is 5, increase here is 7, and increase here is 9. So that's the first difference, but we will continue and find the second difference. So the second difference is 2, so therefore we are using a quadratic one here, and for the quadratic one, remember, it is an squared plus bn plus c. So we know that 2a has to be equal to the second difference, therefore a is equal to 1. From this we can then substitute the value of a, so n squared will be plus bn plus c. Now we can substitute when n is 1 and n is 2, what the term and equation should be. Basically, if n is 1, this is 1 plus b plus c, and that will be equal to negative 3. If n is 2, this will be 4 plus 2b plus c equal to 0. So from this you can see that b is equal to c plus b is equal to negative 4, and also 2b plus c is equal to negative 4. So when you subtract, then this will be 2b take away b is equal to negative 4 plus 4, which is equal to 0. So b is equal to 0. When you find that b is equal to 0, you can find that c therefore has to be equal to negative 4. So putting this information into the original equation, this means I have n squared plus 0 n take away 4, which is simply n squared take away 4, option number 3. Okay, and we have this one, work out the value of the 9th term. So for the 9th term, we are working out W9, which is basically 1/4 into 9 squared into 10 squared. So this is quarter, 81, this is 100. So therefore this is going to be 25 into 81. And when you can use mental maths, or you can use your calculator at this point and figure out that the answer is 2025. Hence the solution is number 3. And when we have the final one, this is nth term is 4n negative 3, and we need to find for n of 12, so that is this. So that is 48 take away 3, which is 45. So the answer is option number 2. Subscribe us now for more videos and content.